Welcome to our presentation on the Haccp plan for Skinless Longganisa, presented by Nabor, Bermudez, Mendoza from BSFT 40. And these are the contents of our Haccp plan: introduction of the product, process information, process flow diagram, hazard and CCP identification, and the Haccp plan summary. First, I will introduce to you our product. Skinless Longganisa, a type of Filipino sausage, typically made with ground pork that contains ingredients such as water, carrageenan, isolate, curing salt, phosphate, and vitamin C powder, and seasonings such as refined sugar, ground black pepper, finely chopped garlic, paprika powder, anisado wine, pineapple juice, MSG, and meat enhancer. Skinless Longganisa is an immensely popular food item in the Philippines. Skinless Longganisa is often served with garlic rice, fried eggs, and a side of sliced tomatoes or achara. While traditionally a breakfast food, it is also frequently consumed for lunch and dinner.
So let's proceed to the product information. These are the ingredients that was used to formulate the product. The first main ingredient is the kanot gel. It acts as a binding agent in the skinless longganisa, helps hold the ingredients together and improve the texture. Next is the ground pork meat, the main protein source, and it provides the base flavor, structure, and the richness of the longganisa. Next one is the chilled water. It adds juiciness and it helps in the even mixing of all the ingredients. The next ingredient is the chopped garlic. It provides the distinct garlicky flavor typical of traditional longganisa. The next one is the onion powder. This enhances the overall flavor and adds mild sweetness and aroma of the longganisa. The next one is the pineapple juice. It adds a sweet, tangy flavor and helps tenderize the meat. The next ingredient is the phosphate. It improves the water holding capacity of the meat and keeps the longganisa moist and juicy. Next is the refined salt. It enhances flavor and helps in preserving moisture. Next ingredient is the curing salt. This ingredient helps preserve the meat and gives the product its pink color. Next is the MSG. It boosts the savory, umami flavor of the product. Next, and lastly, the meat enhancer. It improves binding, texture, and helps retain water during processing and cooking. That are the ingredients that were used to formulate the skinless longganisa. Let's proceed to the next product information. So based on the table, the skinless longganisa was analyzed for its physicochemical properties including water activity, moisture content, crude ash, and crude fat. The water activity was found to be 0.96, indicating a potential risk for microbial growth which necessitates proper packaging and storage, such as vacuum sealing and freezing to extend shelf life and maintain safety. The product's moisture content was 76.66 per 100 grams, higher than standard pork longganisa, attributed to the inclusion of kanot seaweed gel, which enhances water retention and contributes to juiciness but also increases susceptibility to microbial spoilage if not stored correctly. So for its crude fat, it consists 6.26 grams per 100, which falls under the low-fat category and significantly lower than pork sausage fat content, reflecting a healthier formulation. The incorporation of kanot seaweed gel contributed to improved water holding capacity, better texture, and reduced greasiness. This aligns the product with quality and health standards. So let's proceed to the other part of product information, starting the brand name. Our brand name is Seabind Longganisa. The name Seabind was derived from the product's unique feature, kanot seaweed gel, which is used as a natural binder. The branding aligns with consumer trends toward healthier and cleaner label products. Next is the product claim. Our product is the Skinless Longganisa. This is a Filipino-style sausage known for its distinct savory and garlicky flavor. Next is the composition and product type of the longganisa. Skinless longganisa is classified as high risk due to its high water content and moisture content, which are ideal for microbial growth. It contains pork and natural binders from seaweed, making it nutrient-rich but also highly perishable. Next is the intended use. The skinless longganisa is ready to cook. It is not ready to eat and must be cooked thoroughly before consumption. It is designed for quick and easy preparation at home or in food service, providing a convenient protein option for meals. Next is the used packaging. So we used vacuum sealed in polyethylene packaging. Vacuum sealing eliminates oxygen, reducing microbial spoilage and extending shelf life. Polyethylene is a food-grade, durable plastic that provides a moisture barrier and protects against contamination. Next is the shelf life of the skinless longganisa, which can last up to 6 months under frozen storage as -degree Fahrenheit or -18 degrees Celsius. If kept continuously frozen, the product maintains its safety, nutritional value, and sensory quality for up to 6 months. Next is where it will be sold. The skinless longganisa can be sold in retail stores. The product will be distributed through grocery stores, wet markets, and meat shops. The retail setting makes it accessible for household consumers seeking traditional, ready-to-cook meals with a twist of innovation. Next is the intended customer of Skinless Longganisa, which is the general public. The product targets all types of consumers including individuals, families, and even food businesses like eateries and carinderia. Next is the distribution condition. Due to its high risk, it is frozen. The longganisa must be stored and transported at negative degrees Celsius or below to preserve freshness and prevent microbial contamination. Next is the labeling instructions. So the labeling instructions is keep frozen at negative degrees Celsius or below, cook thoroughly before consumption, and it includes the contains which is fork seaweed-derived ingredients for the allergen safety. The label complies with PDF requirements providing essential information for food safety and allergen awareness.
Let's now take a look at the process flow of skinless longganisa. We start with an oval, which marks the beginning of the process. Next, a parallelogram represents the input, pork, which serves as our main ingredient. This is followed by a rectangle where the pork is washed with potable water and then browned. Another parallelogram follows, this time representing the input of canot gel along with other ingredients. These include water, carrageenan, isolate, curing salt, phosphate, and vitamin C powder, as well as seasonings such as refined sugar, ground black pepper, finely chopped garlic, paprika powder, anisado wine, pineapple juice, MSG, and meat enhancer. The mixture then goes through a rectangle where all ingredients are mixed thoroughly. After this, the pork mixture is chilled for 1 hour, another step represented by a rectangle. Once chilled, the mixture is wrapped into oval shapes using paper lime, and then cured in the refrigerator for 3 days. After curing, the longganisa is packed and stored in the freezer. At this point, we encounter a diamond, which signifies a decision point. Is the product ready to cook? If the answer is yes, we proceed to an oval representing this step, cook and serve. Then if the answer is no, another oval directs us to store until needed.
Each step of the process is carefully analyzed using hazard identification and CCP or critical control point evaluation. This helps detect potential risks early and apply proper control to prevent foodborne illnesses or contamination. Let's go through the major stages of the process. The first process is receiving of raw materials. This is the first and one of the most important stages. One of the factors in seaweed is used as an ingredient that may contain stones or shells, which are physical hazard. Likewise, pork, the main ingredient, may carry biological hazard like salmonella, listeria, or E. coli. This can pose serious health risks if not managed properly. To control this hazard, visual inspection of seaweed is conducted, while pork must come from an accredited supplier and is subjected to temperature checks to ensure it's stored under safe conditions. Because contamination here can have a major impact downstream, this step is considered as CCP. Second is the grinding the meat at this stage. The primary concern is physical contamination from metal shavings, which may come from poorly maintained or aging equipment. This is a serious hazard that could cause injury or may be choking risk if consumed. To control it, equipment is regularly maintained and metal detectors are used to catch any fragments. This makes it another critical control point in the process. Measurement of ingredient. This involves the addition of spices, curing salts, and other additives. A chemical hazard here is exceeding of legal additive limits, which could lead to toxic effects or regulatory violations. Inaccurate measurements could also affect the product's shelf life and safety. To manage this, workers follow standard formulation guidelines and use calibrated scales or dosing equipment. This precision helps avoid overdose of curing agents like nitrites and makes this step another CCP. Mixing. This step carries biological hazard, specifically cross-contamination from personnel such as the spread of Staphylococcus aureus through the hair or skin contact. Since this pathogen is common on human skin, hygiene is critical. Controls include enforcing the use of hairnets, gloves, aprons, and strict supervision to ensure all personnel follow hygienic practices. This step is also considered a CCP because it directly affects microbial safety. 5 is the curing or refrigeration. Finally, the longganisa is stored or cured at cold temperature. Here, the hazard is growth of harmful bacteria like Listeria monocytogenes if refrigeration fails. To control this, the product is maintained at 4 degrees Celsius or below, which daily temperature check is using calibrated thermometers and data loggers. This is essential to inhibit bacterial growth, and again, this is critical control point. In total of 5 stages, from receiving raw materials to curing, I identified the CCPs in skinless longganisa production. This shows the importance of comprehensive Haccp system by identifying specific hazard and placing tight controls at each CCP. The production process ensures the final production is safe, legal, and high quality for consumers.